Hi developers, it's Hossein Abdullah, Microsoft MVP. In this Lightboard session, I'll give you an overview of the microservices architecture. We'll start here by showing the monolithic approach. We'll see what are the pros and the cons of such an approach. Then we'll move to the modular application or the modular architecture, where here we'll see how we can divide the code inside the monolithic into different layers or different modules. Then we'll move to the microservices approach, where we go to separate those modules to live inside different microservices, where each microservice will live inside its own process. It will use its own programming language and its own framework. It will also connect to its own database. For that, it is free to use the database engine that it wants. And we'll analyze the different pros and cons of each approach. So let's get started with a case study. We'll take here an online shopping application. We'll start with the monolithic approach, then we'll try to figure out how we can transform this application to use the microservices architecture. So let's start here, for example, by saying that for now our development team started developing the application, and at the first, the application is just few hundreds or thousands of lines of code. But as the application evolves and as more users are getting to use the application gets more successful, and the business team wants to add more features to the application. This makes it really challenging for the development team to add or to implement all those features. So they will start to have a big giant application with millions of lines of code. This is what we call the monolithic. So I'll go to draw this one here. So our app, it's this one. This is the monolithic. And the app here contains all the application's business logic, the views UI, the web API access, the repositories, the different services. All of them are implemented inside this app. So in terms of features, those are the payment, for example, the orders, the catalog, and so on. All of them lives inside the same, inside one application. Now we want to organize a little bit the application's source code. So what we thought it would be really interesting to do is to use the modular architecture. So instead of having all the source code living in one repository, and also as all the code with no abstraction on the different responsibility for each part, here we want to implement the layered architecture and with this approach, the application source code will be structured on different layers. So for example, here we'll have the layer number 1, which contain the module number 1. The module number 1 is for the catalog, for example. And maybe you have another layer for the orders. And this is going to be module number 2 for orders. And the third module for module number 3 for the payment. And of course, we might have many other modules. So each module is responsible for a functionality, for a feature. And with what we gain with this approach is that we have a solution. In terms of Visual Studio, we'll have one solution that contains different projects. So we'll have a project for the module 1, for another separate project for module 2, and actually module 1 might be implemented onto multiple projects. So we might have one project for the web API access, another project for the models or for the domain, another project for the repositories, the services, and so on. So here what we have gained is a separation of of the responsibilities. So we'll have a dedicated module for the catalog, another one for the orders, and so on, instead of having all of those modules implemented inside one single project. So the code is more structured. If I'm looking for the class responsible for the payment, then I know where to find it. I go to the module responsible for the payment. So we started having some separation of concerns, or for separation of responsibilities with this architecture. This is what we call the modular architecture. Now it turns out that this modular architecture is not enough to make innovation faster and to deploy faster and to add other features to the application. Because here I still have millions of lines of code, and as the development team might add other members to help them to add even more features, the development team in itself, it will have maybe dozens or hundreds of developers, and it's really a pain to manage those hundreds of developers working on the same project. So adding to that the complexity of the code, here we still have millions of lines of code, and it's a bit difficult to understand or for a new developer to understand what the application is already doing and to add features on top of this complex code. In addition to this, a third complexity is the deployment of this application. And each time we want to make an update or an upgrade to the application, then we want to deploy it, then we need to deploy this whole application. Even if it is just a small change in one of those modules, we still have to deploy the entire application, and that's really so risky. So let's list those different cons of using the modular or the monolithic applications. So first of all, we said that the updates are a bit difficult to do. So we mentioned the updates. We also mentioned the team management. And the deployment. A third con is the maintainability of the application. In terms of maintainability, if I have discovered a bug in the app, or I wanted to change some applications code, then here the change might impact a small change in one of those modules might impact the entire application, because it is still so coupled together, especially for this monolithic architecture. So with those pros or those cons, we want to solve those different problems. How we can innovate faster, how we can deploy faster, how we can add features so easily, how we can make the team management easier to do. And here where microservices comes into play. So the change with microservices is that here, when we want to go to use microservices, is that we're going to say that instead of having one single monolithic applications repo, we'll have different applications communicating together. So instead of this giant application, we'll go to split this application into smaller applications. Those smaller applications are actually the microservices. Each one is called microservice. So microservice is a small feature or a module or a small functionality inside the application that will live independently in a separate process. So here, this means if we apply microservices to this architecture here, to this app, then this means we'll have different microservices. So we'll go to extract the first module into a separate microservice. So let's say that now we'll have our microservice number 1. And maybe my microservice number one actually is the one that implements the catalog. So here I'll add another part here to say this is the part responsible for managing the catalog of my app. Then we might have a second microservice. So let's say this is going to be the microservice number 2. Microservice number 2 will be responsible for the orders. And microservice number 3 will implement the functionality for module 3, which is the payment. Now, what this means is that we have extracted each module to be a separate application or to be a separate process in my application. Each of one is a microservice that is independent from the other microservices. And those one, because they will live inside different processes, inside different application servers, then we need a way to communicate or a way for communication between those different microservices. Because here, for example, the catalog module might call the orders module, for example. So this means this module will communicate with this one, and the orders maybe also it will call the payment module, and vice versa. So and here, because those modules lives inside the same application, inside the same process, so calling a module is actually a call for an object, is a call for a method inside that object. It's simple, it's still, all of this still will run in the same memory, so it's really simple to call one object. We just call the object name dot the name of the method. But here, microservice number 2 might be running in another region. It might be running in a different application server. So to reach that microservice, it's not we cannot do in-memory calls. So instead, we'll go through the wire, or we'll go through the network. And here we need to either use HTTP calls or use the queues. So for HTTP calls, so microservice 1 might call the orders microservice through using HTTP or HTTPS, of course, with the REST API, or using REST API. And microservice 2 might call microservice 3, not through using HTTP, but maybe through using the queuing systems if we want to use the asynchronous programming, so that it won't be blocked until it gets a response from a microservice 3. So those are the different ways of communication between microservices. Of course, there is lots of other methods for communicating different microservices, because they don't live inside the same process. This means here, it's actually we are implementing the SOA pattern, or the service-oriented architecture. For that, some says that microservices is just the good or the best implementation of SOA. SOA for service-oriented architecture, for distributed programming. So now how this change would resolve those different problems we had before with the monolithic. For the updates, for example, now let's imagine that each microservice, because it will be hosted on a different process, it will have also its own GitHub or its own Git repository, and it will have also its own team members. This means this will solve the problems of updates, because now I won't have one single repository that contains the million lines of code, but I'll have smaller repositories. Each one is responsible for a single responsibility. This means I'll have so much or so less lines of code per repository. Microservice 1 will live inside a different repository. The same for microservice 2 and microservice 3. Actually, we can put all of them inside the same or inside one single repository. But again, we can apply some techniques used in Git in order to separate the different layers or the different features of the application, so that the team will see only its the code for its own microservice. So this solves the problem of updates, because we'll have smaller code. This means it is more easy to understand, and more easy to add features to a smaller code instead of one big giant application. So updates will be easier thanks to using this thing called multi-repo. We'll have multiple repos. Each microservice will live inside a separate repository in Git. The team management is also way much more easier, because here we won't have, as here we did have hundreds of developers working on the same application. Here the development team will be divided into smaller teams. Each microservice will have its own team dedicated to working on it. And actually, a development team might take one or more microservices to develop it. But at the end, we'll have separate teams. Each one is responsible for one single microservice, one or more actually. This means the team now has less responsibility. It knows what is happening inside its own microservice, because one microservice have less features than the monolithic, and the team itself is smaller. It have less members than in the monolithic approach. So the team management is really easy to do here. And here where we are talking about the 2 pizza size team. With this approach, 2 pizza team. This was invented by Amazon to say that a team working on a microservice should not be bigger than a team that could eat 2 pizza. So yeah, that means a team around maybe 8 or 10 developers. So we'll have smaller teams for the deployment. Now it will be also easier, because here each microservice will live inside its own application server, or inside its own function, or inside its own container. So instead of having all those features deployed together, each one will be deployed separately. This means if I added features to microservice and I want to deploy it, I don't need to wait or to care about microservice 2 or microservice 3. If I added features, I can immediately go and deploy those features into production. Each microservice is independent from the other microservices. Of course, and if I didn't change the API interface for the microservice. So the deployment will be easier thanks to the independent deployments. The maintainability also will be easier, because here we have less code. It's easier to understand, and making a change to one microservice in the best cases doesn't affect the other microservices, but if we do respect the best practices, then it won't actually touch or impact the other microservices. So this is thanks to using the smaller changes. I say smaller changes here because if I want smaller change into a big application, then that's still a risky change. But a smaller change in a smaller app, that's really a smaller change. In addition to those different advantages of using the microservices architecture, actually we have other more advantages. Here we said that each microservice will live inside its own process. It's independent from the other microservices that have its own development team. And in addition to that, because those will use protocols like HTTP or the queues, so it doesn't matter what is the technology used inside this microservice. This means it doesn't also matter what is the programming language or the framework I'm using for each microservice. This means I can implement this microservice one using C# with .NET, for example, or using ASP.NET Core, and they can implement the second microservice using Java with Spring Boot. And the third one here I can use, for example, Python with Flask framework, for example. So each development team will use the tools that it wants to use, the tools that it's already familiar with. We don't have constraints of using the same and only one programming language and one framework for the entire application. If the orders module if it would be better to implement microservice 2 using the Java, then I should use the Java. Why to be forced to use C# or Python or other programming language? So we choose the best tools to implement a certain feature inside the microservice. So this adds to the pro of using microservices. So here we'll say multiple or multi-programming languages. Another advantage here, we didn't talk about the database for the application, because here we only talked about the app, but what about the database? We know that the monolithic will connect to the database, so maybe here it have its own DB, and the DB here will contain all the tables related to the application. The same for the modular architecture. So here this will connect to a database, and again the database will contain all the tables, but maybe organized using as we have organized the layered architecture here, we might have the tables organized by domains. So we'll have different tables related to the orders. They will live inside one domain, or they will be related to the orders domain, and the same applies for the other modules. So we have the tables regrouped by domain. And as we have applied the principle of separating the application's different modules into separate microservices, we'll apply the same for the domains of the tables inside the database. So instead here of having one single database for the entire application, we'll have multiple databases for the different microservices. And actually each microservice will have its own database. So this means microservice 1 will connect to a different database, and microservice 2 also will have its own database, and the same applies for my microservice number 3. And here, as we did have the freedom to choose the programming language and the framework for each microservice, I have also the freedom to choose the database engine I want for each microservice. So for my ASP.NET Core application, the database here, I can choose any database engine I want. Maybe here I want to use SQL Server, for example. So I'm free to do that. With Java, maybe I want to use Oracle database. So those are our databases. And with Python, maybe here I want to use a NoSQL database, something like MongoDB, for example. So I have the freedom of using the best database for the microservice needs. Here, if it needs NoSQL database, I go and use NoSQL. I'm not limited to using one single database as in the monolithic. Yeah, in the modular application, we can use or we can connect to different databases, DB2 for example. But here, the separation of the concern or the separation between the different microservices gives me more freedom to use the database engine I want. So I'll note here multi database engines. So those are the different pros of using the microservice architecture. Now what about the cons of using microservices? It has some drawbacks. First of all, implementing the microservice architecture is still yet a very difficult or very hard to do, especially for beginners. So we'll go to note that here as a minus, so the implementation. Another concern is the data flow. What this means? For the data flow, we said that in the monolithic application, we have only one application, so it's a bit easy to understand the different flows of the app. We have the tools that can tell us this module called which module, this the object called which other objects. But here we have distributed microservices, and those will be using different protocols and different async or synchronous methods for communication, and it's a bit difficult to understand what is the flow of the data inside the application, because we'll have many microservices. Here we did only have 3, but imagine if we have hundreds of microservices communicating with each other, sending data to each other, and invoking methods and REST API from different microservices. So understanding the complete data flow inside such a microservice application is a bit hard to do, because here again, because we do have independent teams working on different microservices, it might be a bit difficult for them to understand the implementations of the other microservices, which is in contrast of what we have done here. One team is responsible for the entire application, so each developer can see the complete data flow. But here, that's not the case. Team responsible for microservice 1 doesn't know all the implementation details for microservice 2. It only have the web API interface implemented in Swagger. They only see that specification in the Swagger file. They don't see the details for that microservice. They don't know what is microservice 2 is doing with the data. I hope this Lightboard session was helpful for you to understand the microservice architecture and to understand the transition from the monolithic to the modular architecture and going to the microservices. If you liked this video and you are looking for more content like this one, then I invite you to subscribe to my YouTube channel and to go to follow me on Twitter. So my handler is @HussamDillahi. And thank you.